Okay, today we are introducing the Vernon Smartsolar metering system. This is designed for residential and larger solar grid tie applications where you have a solar panel which feeds DC to an inverter, then the inverter feeds AC to the grid. This circuit board you're looking at meters both the DC power out of the solar panel and the AC panel delivered by the inverter to the grid. It consists of a Technological Arts module that has a 9S12C128 processor on it. That's this device right there. That is interfaced to a set of shift registers over here that run the local 4x20 line LCD display. The SPI bus also connects to an analog device's ADE7763 energy measurement chip. There's also a couple of chips up at this part of the board that measure DC voltage and current out of the panel and basically provide gain and scaling for the microprocessor A to D converter. There's some extra green space on the board. That is because eventually there's going to be a couple of relays on there and some more components to provide solar tracking. In other words, the panel will move and follow the sun, optimizing energy collection. Okay, the device has an internet interface provided by the NetBurner server behind the monitor there. That presentation is shown right here. I have that screen up. Okay, the AC metering, right now the current is off. The AC metering is on the bottom and the DC metering is up here on top. Okay, what I'm going to do now is I'm going to reset this. Here I have a Scientific Columbus watt-hour standard. It has a KH of 0.6, and I'm going to use it and in a calibration run to see how accurate the reading I get on my screen over here. That would, I don't have a KH, I just read straight in watt hours, and that is the E reading there, which is right now reads 0.001. I'm going to reset that and turn on some current. You notice that the kilowatt hour standard is incrementing. Right now it's decimal part of a revolution. Watt-hour standards work in revolutions like the old mechanical devices. Notice that now the first number is red and it's a 1. That's 1 revolution. Okay, we'll let that spin for a while. Notice that over here I'm now reading the current, the voltage, and some AC watts. Since I read 10, the smallest number on the KWH output is 10 watt hours. I won't read anything there. When I get 10 watt hours, that'll increment to a 0.01. I have a clock on the bottom, which now reads 9:40 a.m. Pacific time. That clock is a software clock within the server. And its purpose, of course, will be to perform tasks at certain times of the day. Like it will signal the metering board at midnight, for example, to run the tracking position back to its dawn position so it catches optimum sunlight early in the morning. Okay, going back to this, I notice I have been counting merrily away. I'm going to go ahead and flip off the current at this point. Current is now stopped. I have 5569. So multiplying that by the KH, 5569 times 0.6, I get 3341.4. Okay, going down here, we can see that the E, or watt-hour meter here, reads 3.342 as opposed to 3.341.4 from the standard. So that's a very accurate result there. Like 0.017% or something like that. Okay, and that, once again, give you a little close-up here of the circuit board, a little close-up of the server, and that's about it. The next step, we put this in some kind of enclosure, like a plastic box and then a toolbox to go under the solar panel. I was originally going to do wireless, but now I'm kind of giving up on that idea, and am going to go to an RS422 converter, and I'm going to run a pair of wires out to the yard because the wireless just scrambled everything. I'm not going to spend more money on that for right now. Okay, I guess that's all for today, folks.